Hi, I'm John Dalton, a scientist from the early 19th century. Today we'll explore my solid sphere model of the atom, which I devised in 1803. We'll see how my model was later replaced by Thomson's Plum Pudding model of the atom in 1904.
Welcome back! Today we will begin by taking a look at John Dalton's solid sphere model of the atom, which was proposed in 1803. We will then understand how JJ Thomson proposed a new model of the atom nearly 100 years later in 1904, which was known as the Plum Pudding model. Before the late 19th century, scientists believed atoms to be indivisible particles, which means they are unable to be divided into any smaller parts. They also believed that these indivisible particles were essentially tiny solid spheres without any internal structure. This idea was part of the Dalton model for atomic structure, named after John Dalton, who was among the first to describe all matter in terms of atoms. However, this notion was challenged in 1897 by JJ Thomson's groundbreaking experiments on the flow of electricity through gases, which confirmed that atoms contained electrons. Let's imagine how he would have described his discovery.
I discovered that atoms contained even smaller, negatively charged particles, later known as electrons. This discovery provided the first evidence that atoms were not, in fact, indivisible, but had an internal structure containing these subatomic particles.
This new experimental evidence forced a significant shift in the scientific understanding of atomic structure. Then, in 1904, to incorporate the discovery of the electron, JJ Thomson proposed a new model of the atom known as the Plum Pudding model. Let's take a look at this famous model. According to this model, an atom consists of a positively charged sphere embedded with negatively charged electrons. A good visualization of this is to consider a positively charged pudding embedded with negatively charged plums. The diagram of the Plum Pudding model shows this arrangement clearly, with electrons spread throughout a uniform positive charge. However, this model was later shown to be incorrect. Rutherford's version of the nuclear model replaced the Plum Pudding model when Ernest Rutherford discovered the atom in 1909, which we'll look at in our next lesson. It's important to note that the nuclear model itself is simplified, and there are more advanced models today. This progression from model to model illustrates advancements in science over time. We have seen that each new model replaces the former as we find out new information. Our understanding deepens and becomes more refined. By 1904, scientists no longer used Dalton's solid sphere model, as the Plum Pudding model proved to be more accurate given new findings. And by 1909, the Plum Pudding model was replaced by the new nuclear model thanks to new findings by Rutherford. Different models for atomic structure can and do exist, and more accurate models for describing atomic structure beyond the nuclear model. That's all for today. To summarize, we have discussed John Dalton's early concept of atoms as indivisible particles in the solid sphere model. This idea was widely accepted until the discovery of the electron by JJ Thomson in 1897, which confirmed that atoms were not indivisible, prompting a change in the scientific model of the atom. This was formalized in the Plum Pudding model, which proposed that an atom consists of a positively charged sphere with negatively charged electrons embedded within it. Well done for today, and I'll see you in our next lesson, where we will learn of Rutherford's scientific advancement.